Welcome back to Algebra 1, Chapter 11, Section 5 in this book. And we've been talking about simplifying, which was when you were young in middle school, you possibly hated reducing fractions. Well, now we're going to reduce crazy fractions that look like this. But it's really not that hard, and I really think it's fun. I have this cat who is starting to be a problem here. Anyway, it's very fun, and because it's fancy math. And I also like math when you mark it out. So I always think it's fun to cancel things out. So let me drop her outside since she's being a nuisance, and I will explain it to you. Bye, cat. Okay, so the first thing is to multiply fractions. You just multiply across the top. So this is actually the same thing as that. Because remember, if you have A sitting next to C, it's multiplied, and B sitting next to D is multiplied. So we'll talk more about that in this problem here. Now, how do you divide a fraction? You flip it and multiply, remember? Turn up the radio, blast the stereo louder, and flip it. Flip it. So, if this is divided, you flip the second one and multiply it. It's always the second one that gets flipped. So instead of C over D, it's D over C, and then you just multiply. And at this point, you could just connect them. It's the same thing. Alright, I'll show you what I mean here. This is a multiply. It's really the same thing as if it was all one big fraction, and you're allowed to cross things out if the same thing is in the numerator and denominator. As long as there's no pluses or minuses to make things uncancelable, you can just cancel away, and it's lots of fun. Alright, so what can we mark out? Well, this 8 is made out of 2 times 4, so I'm going to convert it and turn it into 2 times 4, and then I can mark out those 4's because I have a 4 in the numerator and a 4 in the denominator. That 15 is really 3 times 5. So I'm going to change it into 3 times 5, and I'm going to mark out this 3 and that 3. Now what about the x's? I have 1, 2, 3, 4, 5 on top, and 1, 2, 3, 4, 5 on bottom. They get all marked out. Oh, isn't that fun? Just marking out those x's. What do we have left? We have a 2 in the numerator and a 5 in the denominator. So the answer is 2/5. Isn't that fun? They love this problem, the SAT, the ACT, and college entrance exams. It's fast, it's easy, it's fun. Whoop, there it is. Alright, but what about that one? We are not allowed to mark things out if they are connected by a plus or a minus sign. So what we want to do is to see if we can factor or pull things out so we can cross out. And I notice here that this has a 3 that goes into both of them and an x that goes into both of them. So I'm going to pull out a 3x. That will leave an x here and a 3 there. So I'm going to convert it. It's not going to be that anymore. I'm going to mark it out because now I've changed it into this. And you'll also notice that now, remember, this is all like one thing. And now I have an x minus 3 in the numerator and the denominator. And if I have the whole expression, x minus 3, I'm allowed to cross them out. Isn't that fun? I think it is. All right, how about this? Is there anything here that could be pulled out or anything like that? There's really not, because I can factor this, but there's not any more terms up there that could be crossed out with it. But here, notice I have an x here and an x there. So I can mark this out and that out. What do I have left? Nothing in the numerator, so what do I write? An understood 1. And so what do I have left in the denominator? I have a 3 times 2x squared plus x minus 3. Now, this is a good answer. Your book might have one different. Some teachers would go ahead and multiply that 3 into the denominator. I think that's fine. Alright, so how about this one? It's multiply. there's nothing to mark out, but this could be changed into factors, and I could mark out that x plus 4. So is there anything that I can multiply to get 4 but add or subtract to get 5? Yes, 1 and 4. And the signs are plus, dun, I get the great fun, so that's gone now, of marking those out. So what's left? A 7x and an x plus 1. So the answer is 7x over x plus 1. Ta-da! Okay, how about this one? It's divide. So what I have to do first is flip it. 4x over x plus 5 times x plus 5 over x minus 9. Well, what happens to those? They cancel out. What's left? 4x over x minus 9. I don't think they're terrible, do you? Okay, how about this one? X squared minus 9 over 4x squared divided by x minus 3. What do we do first? We clap, clap, and flip it. So how do we flip this one? It doesn't have a denominator. It has an understood 1 under there. So to flip it, the 1 goes up, the x minus 3 goes down. Still nothing to cross out except this is the difference between two squares. I can change that into x plus 3, x minus 3, and the x minus 3's cancel out. What's left? X plus 3 on top, 4x on bottom. So these, you're just kind of looking to see what you can do so you can mark something out, but sometimes there's nothing. Didn't we have one, or was that on the last one? There was nothing you can mark out, nothing you can do. No, we did something on all of these. Usually you can do something. And this is also one of those situations where math teachers like this one sometimes disagree on when you're done. Do you need to go ahead and distribute that 3 or not? I said no. I don't know what the book says. I'd have to go back and look. All right. Hope you enjoy this. I think it's fun. I hope you do too. Math is great.